Hi, Ghislaine. How are you doing? I didn't see you pop in there for a second.
Oh, it's okay. I'm doing good. How about you?
Good. Are you competing in the NCL this time or?
Yes,
Oh,
uh,
good.
I need to practice as usual.
Yeah, I know. I was not able to sponsor a team this time, so um, I had asked, but there was no response. So we will go for the next one. But they said they do have some money coming down the pipe, so we'll see what's gonna happen. So are
Um,
you over at RCC?
yes,
Okay. And are you doing the apprenticeship with RCC?
I no, I didn't I didn't go into the meeting to find out about it, like how to register for it. And at this point, I'm like, since I'm already a student worker for RCC,
Mhm.
like I would have to. I think would have to drop all of that in order to even do the apprenticeship because it's the same reasoning as to why like I'm not haven't really jumped into like doing like a Riverside County job because I would
Okay.
have to dump everything for that's related to RCC in order to work. But it's at this point it should technically be my last year to work, and so I need to figure out what I'm aiming to do.
I think I think that apprenticeship will actually secure the position better for you. In that, it's really a way to get with a company, and there is also a way to work with County of Riverside, and you can still work the 20 hours or however many hours that you're working. Usually they start you with part-time and the pay is better. I think that getting that experience is more tangible. I know that the student worker is probably very flexible with your schedule, but a lot of the employers are working with students to to really assist with their schedule. So yeah, and as you are doing the apprenticeship, you don't have to pay for the tuition for the program that's approved at RCC. So you should talk to Mr. Barry and then kind of touch base with him and let him know that you're interested, and all you have to do is fill out the orientation form and the agreement, and then they have to register you into the system. And with that, like, you don't have to owe for classes as you take the classes in that program. um but it's a way to get experience with the company.
Okay.
Yeah, so that's why I recommend. I think that having a year left is a good time to really build that experience, and so
Mhm.
when you graduate you'll be able to get a good job in your field versus having to start looking when you finish. And that can be very stressful. Or even if you transfer to Cal State San Bernardino or another institution, you're able to still continue and work as long as they'll have you, or you can do Cal State San Bernardino apprenticeship. So
Okay then.
okay.
I'm probably seeing if I could somehow transfer to Cal State San Bernardino anyway. So I'll I'll keep that in mind. Thank you.
You're welcome. Not a problem. All right. Hi, everyone. How are you? Well, welcome to week 6. Um, it's almost half of the semester. It's only a third done. So today we are going to talk about Numba and we are going to talk about Pypy. So if you can, take a look at Canvas, download the assignment in the notes. We're going to go over those. Um, and I also posted a quiz. So let me share screen. It's been really intense. Sorry. I had such a hard Monday. And this week I already know because there's so many things due. We have schedule due for the winter. We have stuff that are due for assessment. But okay, so as you take a look at your Canvas, Sorry. You are gonna look at Unit 6, and that's gonna be due on Sunday. Instead of the homework assignment that I normally assign for the quiz review, I minimize that because I know that you are probably having busy schedule too. But there is a quiz game review, and so if you do that one, you will be able to prepare yourself for the quiz. The quiz is only 10 questions, they're 4 points each. It covers chapter 1 through 4, which starts in week 2 all the way until last week. And they're fairly easy questions. So if you do the quiz review game, you get the extra credit, and then you might win a gift card. And then you also will get preparation for your quiz 1, right? But the chapter questions, I mainly use the assignment questions that we've done. So you, okay, that's fine. Yeah, so if you do it before or after, that's fine. It's up to you. But anyway, so if you want to take a look at that before Sunday, but remember the extra credit is going to close at the end of the week. And so just to make sure that you get that in, okay? And so right now we are going to go over chapter 5 notes. And I was thinking of pairing this chapter up with another chapter, but I felt like it was pretty heavy already. So we will take a look at how we can like ramp it up so we can cover almost all the chapters in the book, so you can have all the understanding of what you need from this course. And then I'll post the video and the lab videos later on today, okay, when I get home. All right, so we are going to do Numba, Pypy. And so here is your note. So this document is going to be a mix, a little bit of the documentation and some resources online, along with some of the content from your chapter. So you start with Numba, which is another library that we're going to work on this week. And like Cython, you are utilizing some of the tools that are built by the industry to really streamline your application. So it's a way that we can use C to really improve the performance of our application. And Numba is written in C. And so a little bit different than PyPy in that in this, it uses the LLVM compiler library, in which it's going to later on in the notes, we're going to touch on that. So it's a good way for us to really implement complicated algorithm into our program and still be able to maintain the performance of our program. And so you don't need to replace the Python interpreter, which is nice because in Cython, you notice that we have to use the C compiler strictly. So you can still run some stuff in Python interpreter like Tawny and Idle. However, there's some areas of this particular library that you find that there will be some error that's going to be generated because the interpreter just doesn't have the functionality that's looking for. So, but for most part, well, we can use the interpreter. So an example of a short little program that would use Numba would be like this. So first we would have an import statement, and we will bring in the library. And keep in mind that everything that we use, we have to install first. So assuming that you already install Numba, right, you can then import that in. And then here we're using random, so we just import random. And this is a clip that I took from their documentation. And so you have a decorator. And when you use the no Python true here as an argument in your interpreter, it's gonna throw a little error. And later in the chapter, it talks about that. But you can definitely define a function. And in your function, you can have different things being processed. So in this case, we would have a for loop, and we would randomize X and Y, and then we would use arithmetic operation to calculate for the condition. And so then we're going to return. So in this one, what you can see is simply we just do an import, and then we just specify that we're using Numba by using the decorator, similar to Python. And then what you have is you would be able to write different functions in your program in Python and be able to execute them. Okay, so this gives you a little bit of history. And for Numba, it's a library that compiling individual Python functions at runtime, and it uses LLVM, which is a tool chain. So at the low level virtual machine, so it's converting your functions to directives. And with the directives, it's able to operate faster. And that's ultimately a lot of these library, that's what it's designed to do. So LLVM is basically it's a set of tools that's to write compilers. And so it's functioning at the low level. And here it talks about how the compilers is written in the wide range of different languages. In the aspect of the LLVM, it's able to put it into the intermediate representations. And so that way it would assemble quicker, and in such that it would compile at machine code level. So C is very close to assembly. And so what you see is that it's going to be boosting up your performance if you use that with your function. So now you know that you can't just use regular Python. We want to make things a little faster, so you can use other library to help your program perform quicker. Okay, and then it talks about how it's inspecting the functions by compiling them using LMB, and then it would implement the algorithm in that it would be able to guess the type, because as you know, Python, it's not a strongly typed language. So it would use inference in order to identify the type of your data. So unlike Python is very close to C++. In this one, we just use Python to write our function. And we would use the decorator like what we talked about. And so that way we can create different types of functions, and we're going to talk about universal functions and generalized universal functions. Okay, so let's take a look at the assignment. First, it's going to ask you to describe the functionality of Numba library. And we can simply say that Numba translates Python functions to optimize machine code at runtime using industry standard low-level virtual machine compiler library. And you can find more details also looking at their information page and their documentation. They provide examples and tutorials and various resources. And I provided the link on your note. Okay, so then using this library, we would then later on be able to improve the function performance. And you can find this on the first couple of pages of your notes as well. Okay, any questions regarding Numba? It's a play between NumPy or NumPy and right, Mamba, which is a snake, and then that relates to Python. So now I'm going to switch back to the notes, and so we can, let me open up the documentation so you can see. So here's the page, and you can run it directly. So you can do try Numba, right? And then you can go try now. So they have some buttons for you to use. And then later on, we're going to talk about parallel algorithms, okay? And see how that would be. And also, this also works in Jupyter Notebook if you want to use Jupyter. So here is the 5-minute guide to Numba, and you can find that tab. it talks about how that would work out of the box with different OSs. Like many of the tools that we've been using so far, you can also use Conda. With the Conda distribution, you can, if you have Conda install, you can do Conda install Numba or Numba. And then with Linux and Windows, and if you want to also, it will also work with NumPy, which we are going to do, and then also CPython. Okay. And this is some of the example that you will find. And again, we would have the decorator. Okay, as you can see here. And as you wonder, why would we put the no Python mode? Okay, so in that argument, what we did was we can have it no Python mode or object mode. So if you're using object mode, and if you are not able to, so in object mode, it's going to be a little slower. And so when you switch it to no Python mode, it's able to give you it gives you a different behavior, in that it would run entirely without using the interpreter. But then in that case, if you do have Visual Studio install on your Windows system, you can definitely install Numba as a package plugin, and then be able to use that. Okay. And it also works straight with Linux and Mac OS. Okay. So talking about installation, we're going to come back to here. And to install Numba, we would then do a pip install command. Okay. And so we can simply do that. Unless you use Conda package, then you would use Conda install Numba. So you can open up your command prompt, and then you can simply say pip3 install Numba. And I did that already, so it should have been satisfied. So important that you read what it's telling you here, that it's going to put it into the site packages, and that's under my Python 3.9. Okay, so if you don't have your Python 3.9 path set up, then it will put it somewhere else. So you want to put it in the Python 3 package or directory. And then as it's using LLVM Lite, so it would tell you that it's going to put that also in the site packages. And to build it, we saw setup tools being used in Python already. So it's already equipped with the setup tool for you, and it's going to put that in there. So all they did was they created the modules that would be needed for the setup, and they put it in there. And then NumPy 1.21, that's also in there. But we can, of course, install NumPy separately, which we saw in the last few weeks. Okay, so then we saw how to install Numba. Now the example here shows you that you would have a regular function in Python, and in this function it's just going to calculate the sum square, the sum of the square, and we would use a for loop to iterate through it. Now what we can do is we can change up that function by importing in Numba and then use the decorator, and then continue with the function. So all you're doing is you add 2 lines to it. Of course, you already have to install Numba. Then once you add the import and then you use Numba as decorator here, you're able to improve the function. And when the function is called, it's going to be compiled and it's going to be faster. Okay, so how fast is it? Well, as you can see, if we compare just Python, pure Python, this will be the time. But when we use Numba, drastically huge difference. Okay, so we can see that it is faster when we use loops. So it's recommended that if when you're using loops, you would use a library like this. So that way, and we're not, unlike Python, we don't have to modify much in the code itself. We can just keep the same script, and then we would add the library and then use the decorator to implement that library. So the example that I pull from the documentation is here. And this is when they use the mode no Python. And that's going to give you the best performance. Okay. So to answer the next question, how do you install Numba library? And again, we said pip3 install Numba, or you can use conda install Numba. So with that, we're able to bring in our package. Now we're going to practice using, Numba. And later in the notes, it actually talk about how to use Numpy with Numba. Okay. So for number 3, I have a simple program. I have a program that uses Numpy, and it's gonna create an array with 10 randomized number. And then I just had it print out the array. And I have a function called double. And what I wanted to do with that is to take each of the index value, each of the random number from the array, and I wanted to multiply it by 2, double it. And then after that, what I want to do is I want to just print that out. So you can take something like this, very simple, and then in pure Python, and then what we can do is we will add in the Numba library. So we just have to add the import statement and add the decorator above the function definition. And so when it's called, it should be it should be faster. Okay, so here is my original program, right? And I would have all the values printed, and I can run it straight with the interpreter, which I use Tawny. And when you use, don't forget to add your plugins. So make sure that I find Numba and install it. Even though you install it on your OS, sometimes, that doesn't bring in, not all packages is going to link properly. So make sure that you have it installed in your IDE. Then we wanted to put Numba in. So all we have to do is we need to put an import statement at the top where we would say from Numba import JIT. You can name it anything you want there. Sometimes you would see you can use NB or something that would represent the identification for Numba. And then I still keep my array information the same. So I declare an array using random from Numpy. And then I just add the decorator. And here we don't have to be fancy. We can just say, use the @ symbol, and then whatever that you name here, you would put that on the next line. So here's the decorator. And then you would keep your function the same as defined originally. And then we just simply call that function through our print method there. So we can see. So as you can see, I'm going to pull this up so you can see a little bit. you will get some warning. Okay. And so when you build this, you're going to see that it's going to go through depending on the interpreter. Okay. Remember that it has an algorithm that automatically type out the data. That means that it's going to find the type. So it's going to go through, it's going to check your data type. Okay. And so that's what you see here. And then when it reads through your function, when it goes through the definition of your function, then it's going to look at the decorator. And here it tells me that it's not able to determine the number type. And so all of this is just information. Okay. And then it also gives me the warning that it was compiled in the object mode without, right, forcing the object, in which you can also pass that into an argument. And so in the back, it's looking at how it's going to be able to iterate through using the loops. And then since I didn't use the no Python mode, right, it's going to go into the object mode compilation. And that's what's going to use. Okay. Now, if you specify the non-Python mode, if you're using Visual Studio, you can make it run on non-Python mode or no Python mode compared to object mode. Because if you're using interpreter, it would stop there because it doesn't know what that is. So you have to use a C compiler. All right. And then the bottom part, it's just basically, it's going to try to match. It's using a function called mod, and it's trying to match the data type by going through the specified data type from the library. Okay. And then I get another warning, right? So these are just warnings. So as it tried to loop, it's gonna, for that function, it's just gonna generate the warning. But at the outcome, I do have the output from my array. Okay. And when we measure this, we would see that there is an improvement in the time if using time it command, right? So if you run it on Linux, or if you're using like Jupyter Notebook, you can also implement the command in IPython for that.
Professor?
Yes.
So when I run my program, it says module not found error, no module name number.
Mhm.
I did do the command line pip3 install number, but
Mhm.
I'm guessing it's not going into the correct.
Yeah. So are you using idle, or are you using another IDE?
I'm currently using idle.
Okay. So on idle, I believe that you have to install it there. Let me see. Because, and did you look at where on your command line, did it tell you where it puts it? It would tell you the path where it puts it.
It says app data, local programs, Python 3.9, lib site packages, and yeah, that's it.
Yeah, so it should be in.
It's the correct one. Yeah.
Yeah, so I think that maybe the idle is not in the same location. Have you tried looking in and see if idle is in the same location? Let me see if I do. Yeah, so you can probably add in. Go to configure idle. Let me see if you can add in the extensions for it. Yeah, it should be. Yeah, you have to open it, I think, in idle, but let me see if there's a better way for you to bring in that. When you, okay, so before you run your program, can you just type in import number in shell like this?
Okay.
And see if it reads it, right?
Okay.
See how on mine, because it's not with idle, it's not able to load it. See? So I think you
Yeah.
have to install it into idle.
Okay. So
Yeah, like how I would do the, yeah, let me
yeah,
find
so
it.
I get the same error as
Mhm.
yeah.
Let me see if I can find the path browser. Yeah, if you look at the path browser. Yeah, okay, so on the idle, it's very similar to yours, I'm assuming for mine. My idle sits in Python Software Foundation. So it's gonna be under a different folder. That's why it's not able to find number. So you can literally in command line, you can literally navigate to that and then put install number there. You see what I mean?
Yeah.
Like, yeah, so that's a way that you can force it to be with the packages, because so you can copy that path and then go into your command line and you would do cd c whatever the path is for your idle, and then you would do pip3 install number there and see if it's going to take it. Either that or having to relink, with the environment variable for multiple things onto the same. But that's what I would suggest for now. I'll test it in a little bit.
Okay, so which one should I because I see there's multiple paths. Which one should I
Yeah, so I think they would be under here. If you navigate to it, so let me see if I can copy this. And then if you go to your file manager, it doesn't let me copy the path browser here. Let me see. Yeah, just under the sys path. So it's under program files. And then we go to Windows app. Yeah, I can't browse to this. So let's try see. When, and then we would say Python Software Foundation. And then .python 3.9. And then I think it's 0.20320 x64 on mine. Okay, so it's .0. I'm gonna make sure that it's .0 and then underscore x64 underscore qbc5n 2k. Yeah, it says I'm missing something here. 392032.0 x86 or x64 QBZ5N2KFR A8P0. I'm just checking my syntax here and see why it's not bringing me there. Program files, Windows app, Python software foundation. Oh, I'm missing. Here, I see it. Come on. It's right here. It's underscore 3.9. 3.9.2032.0 x64. Yeah, I'm just checking to see where if there's any kind of options, but because it doesn't want to take me here. System cannot find the path specify Windows app. Yeah, so under here, let's see. It does have packages. Okay, 1 second. Oh, I see some chat. I'm using idle and yeah, I think what happened is if idle doesn't have a environment path, Michelle. Yeah, and that will probably why it's not. Okay, let me see if I can open this up. So Michelle shared something for installing Number for the idle. You can try that, but yeah, I think the issue is that it's not in the same directory. So in a little bit, let me see if I can like reinstall my idle and see why if it's not. Yeah, because I noticed that the path on yours is probably the same. So it doesn't have the environment variable linked to that. So we can set it up. Yeah, because I think I set mine to default to Tawny whenever I use Python. So okay, but what you can do if you wanted to do command prompt and write, right? After you do pip3 install Number like this, okay, and it's installed there, okay, then you can just call up Python 3 and then write your code directly in there.
Oh, okay. Okay.
Yeah,
I'll
you
go
can
ahead
do it
and
that
do
way.
that for now.
Okay.
Thank you.
All right. So any other questions? All right. So then what we're going to do is we're going to talk about, actually, we're going to do that one. We did that one, right? So you can see here, okay, we added this line and then we added this line to the original program. And then we rerun the program. Okay. And then you should have your output. It seems like it's longer, but because it's giving you all the warning, and you can suppress warning. You know, you can put in some suppression. You just gotta look at the library and see where you wanted to turn off some of the warning. But because we didn't use no Python, so it's giving us the information that's using the object mode instead of the no Python mode. Okay. All right. Then next, after you create that program by adding in 2 lines, then we are going to talk about signature. So type specialization is a way that we can expose a certain type using the signature attribute through the library, Numba library. And in the text, it shows an example where they use the first example that they have, which is the sum of square. And they simply add in the attribute signature so that way it can inspect the available specialization of the type. So then how they use this is you simply add in, right? When you use that method, you simply add in the dot signature. Okay. So this is a way that it will compile all your types quickly. And because in the case where if we have a certain data type, we can specify that. So in this example, they're using float 64. And then later on, when they're trying to, and when you see that they have 2 different signature, one is going to be for the float 64-bit. And then for the second signature, it's going to be for the float 32-bit. So what they have it printed out was just the data type. So it would say that what type is that array, the first array, which is typed as 64. And then the second time they have it typed at 32-bit. Okay. So in the case where you have various type happening in your program, make sure that you set up each signature for each type, because when you start mixing them into one signature, it's going to throw an error. Okay. So it tells you here that an individual signature can be passed in the tuple that contains the type in that we would accept. So it would provide you with a various type of modules. So that would be NB types. And that will allow you to have different data type being used inside, but you have to have one signature per. Okay. So it's able to type it for you. Now, in the next example, it says that it's giving you an error here, because if the definition is for 64 and we're trying to define it as a different type, it's gonna throw an error. Okay, because it's gonna revert to the signature that was created for the float 64, then it's not able to convert it to float 32. So if you want it for float 32, then you have to create the signature for that particular type. Okay, otherwise it's not able to find the definition for that particular type. So that's some of the example you can see on how signature can be used. Then you can also pass multiple signature by doing this. You would use the colon inside the square bracket. And in the parameter, so let's say that I wanted to use 64-bit float, and I wanted to convert that to 32-bit float. And so I can do it this way. Okay, otherwise I would have to create a signature for each data type. As I go from 64 and then I wanted to type it as 32. And when you started to work more with data set, you're going to find that this can be important in that when you use a library like this, you can implement its signature and also do, different use different method to be able to convert it. So a way that we can pass multiple signature is using the colon inside the square bracket. And what this is a string object. And so when you type it as a string, it treats it like an array of char, right? And with that, it's able to handle, that container is able to handle the float 32 data type that you tell it to convert from 64-bit. So this suffix simply is just a way that we can first type it as a string and then convert it into 32-bit. Okay, so that's how you're able to do that. So for number 4, it asks you, when using signature attributes in Numba, how do you avoid error after explicitly declaring the data type? So you must use the same data type after the data type declaration using Numba's signature attribute. So if you define it as a certain type, then you would have to use the attribute signature for that type. Or you can pass it as an argument using the colon in the square bracket, which is as a type string to declare the multiple signatures. So that's how we can avoid the error, is to either create one signature per data type that we define explicitly, or we can use the type strings in the declaration for our multiple signatures. So that would create multiple signatures under the type strings. Okay. Now, keep in mind that this chapter only gives you some of the highlighted areas, right? The library itself is very large. You can find a lot of the details and the use outside of what's given to you in the textbook. So I encourage you to take a look at how to use the library more effectively outside of what we just see as in doing the generalization for the specialization type, or just the specialization of the data type itself. So again, what we can do is we can also use the JIT, the JIT decorator. And if you use it as a generated JIT, that would allow you to control the specialization at the compile time. So it's intuitive in that it's going to select the data type that it would be in your program, that it could infer in your program. So then if you go a little bit further and if you use the decorator, what it will do is it's going to allow us to control which data type it's going to be for the JIT. Now, that is important when you deal with user input, right? Sometime that we would create a container and then we would store the inputs, and we need to either type it as a different data type so we can process it. So in the sense, we don't want delay. So what we can do is we can use the generated JIT decorator to be able to control more of the selection. So that way we don't utilize up valuable resources more in overtime. Okay. So it tells you here, oops, sorry, that the decorated function doesn't compute a result, but it returns a callable definition that's given certain type. So you can do a pre-computed data at the compile time, in which you would be able to use nan or something that would represent the missing variable, and then you can reuse it. So in the example that they gave you in the documentation, what this does is it's a function that we are able to use isNaN, right, as just like a placeholder. So that way, when we compile it, it's able to generate some form of type for us, so that way it will execute the program. So the function definition is used the same names as the argument in the decorated function, which allows you to pass the argument by the name. Okay. So here what we see is we would have X, and then for the X, we would say that X is going to be part of NumPy, but it's going to be isNaN. And then we would then put in NAT, which is the name that's defined inside the argument. Okay, and we're just going to have to return X. And this is just an example, like I said, right? So the way that they had this use is with the date and time. And so we're not sure how we're going to type date and time yet, right? Where is it going to be string, or is it going to be integers or long, right? So what you can do is you can use it this way, so that way you don't have to narrow down to one specific type and then having to convert it down the line. So for the next question, it asks you, when should we use generated JIT or generated JIT method decorator? You would use this decorator in the functions that implement different input types to be able to select the specialization at the compile time without jeopardizing the runtime speed of JIT. So that way you don't slow it down, but you're able to implement it where we would have different input types. Okay. Because if you're looking at an example with date and time, the date can be in a different type compared to the time. So as we have them mixed together in the application, what we can do is we can implement this, we can implement that, and then to be able to build our program without slowing it down. Any question? Okay. So in the next part, we are gonna look at object and native mode. And it starts with talking about Numba is, it cannot infer variable type. And this will be the object mode in contrast to interpreter free scenario, that will be the native mode. So as you saw my program, right? Since we're not using no Python, it's going to revert to the object mode compilation, as it did not see the argument here, right? So if we add the argument there, then it's going to go into the native mode. Now the object mode, it's going to be a little slower, right? And so it uses the interpreter. And as I'm using an interpreter to run my program, it's going to have to use object mode. So there is a function called inspect type, and this is how it's going to look at the type inference that it can optimize. And so you would then add in this method to your function that you define. And in their example, they use the sum SQ, which is sum squared function, and then they would use the inspect type. Now, after that, what you would see is it's going to go through and it's going to take a look at the type right, of your container in the program. So in their program, what they have is they have the float 64, right, for the array that they created. And then it's going to look into the function length. And in that function length, it's using that function for the 64 float. And then it converts that to int 64, which is integer. So what it's doing, it's going to print out the description of your variables, your functions, and intermediate results. And that's what's designed to do, is to give you the detail about your container and the affiliated functions of those containers. So then if you compile the program and not use the interpreter, that would be the native mode. So in such mode, right, what it will do is it's gonna, all the variables will be in a well-defined type, and it's able to compile the code. So the way that you look at this is when it uses the interpreter, it doesn't fully compile the program. It's still interpreting the line, but it's applying some of the methods from the library to be able to execute at the low level using LLVM. In the native mode, what you would see is that it compile your program and then execute those functions. So it would then evaluate after the fact that it's already been compiled. Okay. So for number 6, it asks you, when is the object mode used? So when you have types that can't be determined, or when certain operations are not supported. Okay, then we can use the object mode. Which we can use directly inside the interpreter. Any question? Okay, so now what we will do next is we are going to we're going to modify the number 3 program, and we're going to have it inspect the type. Okay. So as you recall, here's my number 3. And then I'm going to go ahead and show you the number 6 or 7. So I'm still using Numba, and I'm going to import in as JIT. I'm also going to use NumPy, as I would do that for my array creation using random. I still have the decorator, and I still have the same function. The one additional line that I added was I wanted to use the function name, and I wanted to inspect the type. So as you look through the output, it's going to give you a lot of different things. So it goes through your entire program, and then it's going to evaluate the decorator, and then it's going to go through. Now, if you are familiar with assembly, you know that this is where all your variables, all your identifier are labels. okay? And when it moves into certain part of your program, like your loop, right? Because when you finish the loop, it has to come back to the beginning of the loop again. So it's actually doing a jump. So this kind of shows you a little bit on the low machine level. Okay. And so as it's looping, it's going to move in, it's going to use a certain label like your index and your variable and so on, or your array. And then as it does the operations, right? So in these, what it's doing is it's showing you the description of your functions in your container at the low level. Okay. Any question? And then it creates a Pi object here. So as you can see, let's see a chat question. I don't see that in idle. So when you put into idle, you added the one more. You gotta make sure that you do inspect type. Does it give you that? Okay, so it's only giving you the same output as number 3 with the inspect type. That's interesting. It should give you at least some details. But with the double array float 64 at the end. Yeah, so that's all it's gonna give you that. So it gives you okay. So that means that that interpreter, the idle interpreter, it doesn't print all the details within. But you do get that one line. So that one line just state that what it is and what type it is. Okay. So I think that also the software, how it's created, if the software, when it sees a certain, because what it does, it takes this and it converts it into commands. And if this command matches up with what they instructed the software to do, the directives, then it's going to give you more details. Yeah, so on Tawny, it actually gives you the inspection stages, okay, compared to idle, that it just gives you the outcome. Okay. Okay, try it again. Okay, but ultimately you are going to get the n length a, right? Which is what the number of output, and then so okay, so it tells you that you can scroll through, you can take a look at the output. Then for the compilation with the native mode, it's going to also give you some details about the actual program summary. I see a chat question. It's all three. It's 145 lines. Okay. Yeah. Yeah, so some of these library, you're gonna find that we're gonna take, our code, which is usually like very short. And then when you apply the library, it's basically run it through lots and lots of code, and then it's gonna be able to use the algorithm in the library to be able to give you some kind of information about your program.
Professor,
Uh-huh.
so on command prompt, when I type in Python 3 and the shell comes up and I put import number,
Mhm.
it still gives me the error that says no module name number found.
Okay, so that means that, so can you do this? Can you do number version?
Okay.
Oh, I'm sorry, V, right? I think Windows uses -V. Well, it's not coming up on mine. Okay. I did install it, so let's see them. Yeah, it's not able to find it, but let me see. So my site packages, it puts it under lib. Did you check to see if your environment variables is already there? Let me see. So on yours, it just says that it's not pip reinstall. Mine is already fulfilled. Okay, let's see. Let's see what you have. You can share screen now.
Okay. Let me go ahead and share this screen. This is what I have.
Yeah, so above that, it prints that fine. And then I see that when you try to use the inspect type,
Mhm.
so yeah, when you try to use inspect type, it's not able to find it.
Yeah.
Oh, it says attribute error, object is attribute inspect type. Yeah, so if you do import number, and it's doing that again, it says stand in the module. Okay, no module. Okay, let's see. Let me try something real quick. I think I'm gonna check. Go ahead and check your environment variables for your Python 3 packages.
Okay.
Yeah, I don't know if you had reinstalled it or.
Programs or
System, and then system,
advanced.
and then advanced, yeah, on the right. And then under environment, go on path at the top, edit. Yeah, so see how your path is
Mhm.
on, you only have it up to scripts.
Mhm.
And so, let me see, let me compare. Sorry, hold on. Okay, so it should be data local. Yeah, so your app data, local
Mhm.
packages, Python. Yeah, so the fourth one on there is to, it's to the, it's to some packages, but not Python itself, right?
Mhm.
Okay, so go ahead and click on, actually, go back to your command line. Just minimize that. You can just go to your command line in front of it. It's not a big deal. Okay, and scroll up all the way to where your path is.
This is what I have.
Yeah. See
Down.
how it says requirement for the setup tools, it says successfully installed. You see the path where it says C, requirement already installed, setup in C, installing, collecting packages, numpy, LLV
Yeah.
successfully. Okay, so it looks like it puts it in that path, C user. Can you copy that path right there?
Yeah.
All the way up to site packages. And then right click or control C, and then go back to your system. New. Click OK. And then go, wait, click
Oh.
environment. Yeah, go to the path on the bottom.
Oh, this one.
Click edit. Okay, so let's do a new one there.
Oh.
Click new and paste. Click OK.
Okay.
Okay. Okay, let's check your Python and see where it's at. You can just do Python version, Python 3, I'm sorry. Yeah, I want to make sure. Okay, so you have a 3.9.7,
Mhm.
and then do a pip3 install number and see if it's showing that. Okay, it does say that it's already satisfied, right?
Mhm.
We're already in there. Okay,
Yeah.
now hold on, let me see if you can call an idle on here. Hold on 1 second. Type in idle in your command line and see if idle pulls up. Okay, now type in import number. Yeah, so idle is not linked to things still because it's it's catch 22, isn't it? Okay, you can close the idle. We'll fix the idle later.
Okay.
Okay, now call up Python in your command line and then do import number and see if it pulls it. Yeah, it's not able to see it. Yeah, the issue on this is I think it's putting it into 2 places. The one that it places there when we do the pip is correct. but yeah, you're not able to use it like this. Okay, let's pause that here. Let me see if I
Okay.
can help you fix it in a little bit.
Okay.
Okay. Yeah, so in the meantime, we'll just try to finish this, and then you can come back and finish out
Okay.
that one. But the other one works, right? Everything works in except for number packages that you have.
Yeah.
Okay. All right. So let's see. Yeah, I think that when you sometime if you install and then if there's only one, the first version, um it if you check the path option in the installation, it automatically puts you in the right path. But if you have upgraded over many different version, it loses the directory. And that, I think that's the problem, is that if it's already been installed once, and then if you install on top of it, it's not able to identify and place all the packages in the right path. So I think on Sonelli's, some of it is in the app local, kind of like mine, which is in idle, and then all your other packages is in the other one. So we just gotta make sure that we link it. And then let me see how we can fix the problem without having to do too much uninstallation there. Okay. Let's try to finish this, and then in a little bit, I should have time to help you fix that. Okay. So on the next one, we already saw how inspect is going to be. It's going to give you some details about your container and your function. Then for number 8, you are going to look at the function that's given to you here. And then we are going to use NumPy, this one, and we are going to create a universal function. That's going to be NumPy vectorize. And as you recall, a vector is a container that is like an array where it can grow, right? It can grow as you add in more elements. Now, vector can be pushed in. As you push in the element you added in, it will be the last one on the right hand side. So it's the last one, and when you remove it, it's going to be the first one out. So last in, first out. So as you add in the element and you want to print that element, right, it's going to go to that one that it just add, and it's going to use that one first because it's on top of the stack. Okay, so in the notes, it talks about vectorize. Let me go here, scroll down a little bit. And it was originally created, Numba originally created for NumPy arrays. It works best with NumPy arrays. And universal functions are just a way for us to operate the arrays that would have different sizes and different shapes. So instead of writing one function for a specific shape and size, we can write a universal functions that work with different type of arrays. So now in Numba, that will be called ufuncs, but in NumPy, you can use different type of method like vectorize. So the vectorize function is allowing us to broadcast the feature. So an example of a broadcast is to use matrix, like how, or you can use array and multiply it with another array, or you can use an array and operate some kind of arithmetic with another array. And so the example that they use here is called the Cantor pairing function. And so they just have a function that's defined, and they're using variable a and b. Then they're going to return in that it's going to take 0.5 and it's going to multiply it, and it uses distributive law. So we would take 0.5 times a times b, and then take a plus b times a plus b plus 1 plus b. So it's going to distribute the 0.5 with each of the variable and multiply it. then it's going to also take each of the variable and multiply. And that's what we see it as a broadcast is you're taking the value and you're dispersing it, or you applying that value across each of the element in the array. And so in the vectorize, if we use a decorator and we use numpy vectorize, we can place it on top of our definition for the function, and then we can simply call that array or call that function and then pass that array. So it's going to be able to give you the detail about the result for that array. Okay. So now this universal function works with C, it works with Python, and it works with Numba, but Numba is going to be the fastest because it's the easiest, where you just add in that decorator and then you'll be able to output your result. Okay. And so let's try it with the next one. So here you have a function called, we call it test u func xy, and I tried to use something similar to the book so that way you can see. We are going to return integers. We're going to take 0.7, we're going to multiply it by x plus y, then multiply that by x plus y plus 2 plus y. So we would do the arithmetic operation in the distributive manner. Now, when you put this into the program, you simply just, whatever that you import numpy in as, you would just use that with the vectorize, and then you would use the decorator. Okay. And then we can simply do, I wanted to print, and then call the function in the print method. Okay. So here I would have the output 105 and 105, 141. So what it's giving me here is it's able to operate this using the value that I specify here. Okay. Now, if you're missing a parameter, it's going to tell you that you can't detect Y. So make sure that you have all the parameter correctly done. Okay. But when you look at this, when you use the vectorize this way, it's going to output a one-dimension array. Okay. As it apply what would be X and Y, and it does the multiplication, right? And then we told it to convert, to parse that into integer. And so it's able to disregard the type. After it parse it, it will just convert everything to integer anyway at the end because we parse it, and then it's gonna give you the output. So it would operate it like almost it's gonna treat the type the same, even though we have the 0.7 here where that should be a float, right? And then we had it convert to integer there, so that way it looks whole number at the end. But what you see is that you would see that we would be able to write a function to be able to compute values that might be in different types and variables that would be in different type, and then to put it into a container like an array. So then so when we have this output, we would see it like this. And that's how you would use vectorize. And on this one, Sonali, I think you can do this one because you have numpy installed.
Yeah, this one works fine.
Okay.
Yeah.
Just the other one that's not in the
Yeah.
same directory. Okay. So as you can see now, right, we can just simply write Python functions and then we bring in the library, the appropriate library that we want to implement for performance, and then we just use the decorator. Depending on the purpose of that function, you can use a certain type of decorator. We start with profiling from the beginning. Now we go all the way up to how we would control what would be output in our array from the shape. Even though, right, our shape was different and our type was different, we're able to streamline that through using what's called the universal function. And this is only one method in that universal function category. So you will be able to find more as you take a look at the details in that in the documentation. Okay. So any question? All right. The next part, it goes over generalized universal functions, which is GU func, right? And here, this is an example of universal functions, or generalized universal function would be doing matrix. If you ever work with matrix, right, you would then use row and column and how you would apply the value. You would take the value from the column and you multiply across the value on the row, and then you would continue so that way it would be cross-checking or cross operating, you know, in your matrix. So an example here, what they have is they would have a function that was already been created called matmul, which is matrix multiply. And we can simply have one array, and that's going to be shape 3, 3. And then another array B with random number, the same shape. And then we would have an array C in which we would multiply array A and array B. Okay. So basically we would do a matrix multiplication with one array and another array. And when you do that, you would see that it's broadcasting because it's going to take the value and it's going to operate over the arrays of scalars. So that means it's going to go over the column and row for each of the single value, and it's going to compute and it's going to give you the output, right? The whole point is to really streamline the process, and we want to make it go fast. Okay, so here it talks about how it would broadcast over the array of arrays. And then it's going to take the matrices and it's going to match it. So in the case where you have a mismatch, right, in the matrix, it's still going to shape it so that way it would contain the shape that we tell it here. Okay, so we would say a 3 by 3 and a 3 by 3 here multiply, and it's going to take on the shape where it's going to broadcast the content of A with the content of B, and it's going to output C. Now on this one, this is a 3-dimension where you would have a new array that contains 10 results, which is in C. And then you still have the shape of 3 to 3. So it's going to output matching these arrays. Okay. So this is a way that we can implement a generalized universal function. So whenever that you deal with broadcasts where you would need to take a value and you would apply that value into a group of values, for example, in the array or multidimensional array, what you can do is you can implement a generalized universal function. So in the next one, what we're going to do is we are going to write the script that implements a generalized universal function using NumPy matmul to multiply two arrays that contain 5 matrices in the shape of 3, 3. And we can use the example from the book. So that's really easy. All you have to do is you need to import in NumPy. And then you just need to define your arrays. So I just use like the textbook instead of A and B, I use X and Y. So my X is going to contain random number. The shape of it is 3, 3, and it has 5 values. So like you recall in the last few weeks, 2 weeks ago when we worked with NumPy, right? There are 3 parts in the parameter in your argument. The first part is going to be the number of elements, and then the second 2 parts is going to be the last 2 parts is going to be the shape. So I want X and Y to be about the same size. And then I want to multiply X with Y array to be able to get me the Z. And then I want to print the Z's to see what it looks like. And then I wanted to print its shape. So starting from here, as you can see, so this is going to be after it multiplies, right? The X and Y matrix, it's going to give me this. So I have 5 matrices, 3 by 3. And so this is the output for Z. And then Z is also going to take shape of 3, 3, and it's also going to have 5 matrices because the X and Y. So what it does with the generalized function is that it's just going to automatically create the container that will be fitting based on the other arrays as they are passed into the argument here. So as I use X, Y, it's going to determine the size of Z from X and Y. And it's going to be able to broadcast and apply the arithmetic, which is the multiplication, and fill in the value there. Okay. Any question? And in this one, we straight use NumPy, right? We're not doing anything special with Numba. So as you can see, you can use NumPy to be able to operate this on an array. We've seen that in the past. Any question with 9? So that's what you would see as, this is what we would use matmul, right? From NumPy, that will be your generalized universal. Now, if you want to elevate this and use the vectorized, the GU vectorized, like what the book describes, you can add in the decorator and the type. Okay. So when you do that, what it's going to do is going to create the signature for each of the type of your matrices, okay, or your container. And then when we define the definition, what will happen is that it's going to utilize, it's going to revert back to this, and it's going to infer that particular data type to be able to type it for the output. Okay. So this is a way that we can use GU vectorize, which is your generalized universal vectorize, and that's a decorator. That's how it's used. So by doing this, compare this to just using NumPy, it's going to be faster. Okay. And then from NumPy to what you see with original pure Python, using lists, NumPy is faster. So as you look at some of the implementation, you would see that, you know, you have some component from that library that's going to improve the performance based on the method that's been written. Okay, so for the next two, so in the last part of Numba, it talks about JIT class. And JIT class is used when you're implementing data structures with objects. And an example that the book uses is your doubly linked list or your linked list. That means that we can add items to the front of the list and the back of the list, but ultimately it is still a container where we can push in from the back or we can push in from the front. And in that, what we will do is we would have a class and we can create an object class. And inside it, we would use its members. So in JIT class starts with page 13. Here, what you would see is that for Numba, we can use that to implement with our classes so that way it will compile the class quicker. And when it builds that class for the object, it's going to also create a location in memory for all the associated, content of that class, which are members, right? Your variable and your functions. And so when inside your class, you would have members, which are variables and functions. So now then it's going to be able to give you a way to be able to access the data structure quicker. So the example that they have here is a linked list. What a linked list does is that you would have sub-container that would be called node. Okay. So abstract level wise, you just have to create a class called node. And then inside that class, you would have a variable and functions to be able to use with node. So think of node as just a subcontainer inside that class. Okay. Visually, you would see that, let's say I have node 1 here. It's going to point to node 2. It's going to point to node 3. And that's what we call a linked list. And on a doubly linked list, the ending node is going to point back to the beginning, where it's going to be linking back to the beginning. So it is a non-ending list. So inside a node, we would have a value and we would have a way to point to the next node. We would say that. And in Python, you don't really use pointer. You basically just do reassignment. Okay. So here we would then first declare a class called node. And inside it, you instantiated these members. And then you have a second class called linked list. And in this class, you would basically draw out what your list would look like. Which one is the head, right? And then, so what happened is logically you have to put, right? You have to say which one is the head and how it's going to push the value in, how it's going to add that value in. So we would have a function called push front. Okay. And then it's going to be putting in the node value. Okay. So it's going to take the first node value and it's going to put it in for the head. And then it's going to go to the next. And then that's going to be the new head. So this is how normally you would see that this is how we write the linked list. Now what they did was they have a show value in the node, which is a method, a member method. And what that does is it's displaying the content of that node or the value. And as I said before, how are you going to go from one node to the next node? Think of it like a train where it's linking all those cars on the train together. Well, there has to be a way that we can link them. And in Python, instead of using pointer, that's what you would see in C++ or Java, you would then you would link the node by reassigning, by using the assignment operator. You would say a node is going to be the next node. And that's how it's going to be able to go from the first node to the second node to the third node and so on. And at the last one, if you're doing a single linked list, it's going to have no next node on the last one. Okay. But on the doubly linked list, on the last one, you're going to have to use the assignment operator and link it back to the head, right? Because you already specify which one is the head. Self.head is equal new head. Then you're going to point it back to the head by reassigning it. And that's how you're going to be able to have a doubly linked list. This is just a way that we would at the abstract level to create memory locations that store values and associate those locations to what we see as a container and connect them together. And that builds a next level data structure. So when you do a linked list, you are going to push, right? So when it pushes, it's going to take that value and it's going to put it into the node as you already say, you know, how it's going to be stored using the other methods that you define. So if I push in 1, 2, 3, 3 is going to be the last one that's in, okay? And so when you show it, it's going to take 3 and it's going to show that first because it's going to stack last. Think of it like you have plate 1, 2, and 3. 3 is on top. So if you want to flip over the plate and look at the number, it's going to, you can only access 3 first and then 2 and then 1. Because it's last in, it's going to be the first one that's out. So it's going to show first. Okay. So it's always going to be the inverse of the order that you want. But if you want that to be in specific order, like if I want to show 1 first, I have to push 1 last. So 1 is going to be in the back and 3 is going to be in the front. So that way I can show 1, 2, 3. But if I push 1, 2, 3 in, I can only show 3 first because 3 comes in last. It's going to access that first. Okay. So as you connect it, think of it like a chain action. If you connect it, it's when you add in the last car on the train, that's going to be the one that's going to show first. Okay. And that's going to be the one that's going to get removed first. And we've seen push pop before in your pure Python, but this is just going to give you a little bit more example about how you can put together the linked list. Okay. So here, what they did was they used the decorator on top of the definition, before the definition of some list. And then below that, we would have the node is going to be the head. And then what we're going to do is we have a while loop, and the result is going to be the node value, the increment of the node value. And then we reassign it. So we point it to the next node, which is in a different location, and so on. So when you compare this, right, the same program, if we take that and we take out each of the function and we measure the time, it will tell you the time that when you using the decorator, it's gonna be less. So JIT class decorator takes a single argument that contains the attribute types. And with that, the attribute types are integer 64 for the value of the node for next. So we can measure this by just applying the decorator and see how the difference in the time would be as the output. But also you got to keep in mind that this is less inputs here. Okay. So if you increase in the input, how close is it going to be? Not drastically higher like what we've seen in the others, but slightly better. Okay. So additionally, it talks about using optional, that can be an optional variable, and that can be none. So as you build out your node for the linked list, you can see that at the end, right, like I said, on the last node, you will not have any next link. So the limitations for Numba, there are some stuff that's still being in development. And it talks about it cannot properly infer variable types and will refuse to compile. So in some cases, like the example that show here, it will not work well. Okay. So it cannot fingerprint in it, for the empty list in the result. It does not like that. So you will not be able to create, you will not be able to compile that. And then another library we will touch on in our lab this week is going to be PyPy. And PyPy documentation and information is listed there. They're actually pushing all their stuff out of GitHub for most part right now, but there is an information page. You can take a look at it there. This is written in R Python instead of C, like the others. They are written in C. But R Python stands for restricted Python. This is just a subset of Python language. And it the code is executed using the interpreter. So it basically emphasizes the use of Python purely, not necessarily having to go Python with C. And the compiler is going to use the trace operations, and it's going to be able to compile, and it is interpreter free version. So when you download it, what it will give you is the zip folder, and then you have to unzip it, and you have to be able to install it with a third party, either with pip, or if you're using Visual Studio, that's recommended for Windows, and so on. And they want to replace CPython interpreter. So to install PyPy, you are going to download it over here, okay? And when you download it, you're going to see a zip folder. I'm going to show you that like this. This is for Windows, but if you're using a Mac or a Linux, you can find the packages there. For Linux, you need to use tarball or zip to decompress. And then for Mac OS, you need to also download the package, and then you need to decompress and install. But please read the documentation and it has the binary build, okay? For Windows, it tells you here that you need to have, you will need runtime library from Visual Studio. And then for Mac OS, you have to have High Sierra or newer. On the Linux side, if you're using Debian like Ubuntu, it works fine. And then if you're using CentOS, there's certain version of CentOS that's compatible. Okay. And then if you want their instructions, you need to go to their documentation and be able to get more details. Okay. All right. Let's answer the last one, or the last two. How do you install PyPy? You would visit the download page for PyPy, and then you would select the precompiled binary package for your OS. You would need to decompress file and use third-party tool to install. And I put that you need to see documentation. There are two other projects that we're mentioning in the book, and that's at the end of the notes in the chapter. Piston and Nukta, and this is the replacement of Python interpreter. So it compiles every language construct to CPython versions. And right now, I think it's compatible with Python 3 and 2. So it takes Python and translates it into a C program. And then it's gonna compile like what you see in Python or CPython. Piston is a fork off of CPython 3.88, and it optimizes performance by 30% about. There's still some development in both of these libraries, but you can definitely take a look at how you can use them as you already learn about CPython. So it's going to be very close to it, as Piston is a fork off of it. And the other one is built on CPython. Okay. And Python was built on Pyrex. So all of these libraries, what you see is, except for maybe one, right, we would see that they are written in C. And because C is fast, and it would use compiler instead of interpreter. So that will be more useful if you are writing modules, or you creating libraries, or you want to build large Python applications. That requires faster performance. So lab this week, just to minimize some of the issues, we are going to use Linux virtual machines because, you know, I don't want to write 3 iterations of instructions for different OSs. So it's just, and you would see that, you know, for development area, Linux is preferred too. So it's just good to use. So you can use your Ubuntu virtual machine again, and then be able to write your code directly in it using terminal. Yeah, you can use Raspberry Pi as long as you can install your packages on there. Pi is very friendly with packages, so yes, you can pull your packages. It's Debian, so same command. Okay. Any other questions?
Professor, can you help me with question 3 and I believe it's question 3 and 8.
Question 3. I think this you don't have number, right?
Yeah.
I'm trying to see where we can fix with your idle. Hold on 1 second.
Okay.
Yeah, so everybody says using pip3, but let me see. I'm trying to see if there's a better way, but idle is very limited. Okay, let me stop recording real quick so I don't have to cut the video.